Okay, for topic 6, we're going to talk about finding the area of a sector of a circle. Okay, so again, just like when we were talking about how to come up with a way to convert between degrees and radians, we kind of started with stuff that we know, and then we built this idea of what we didn't know. So we're going to do the same thing here. So there are a couple of things that we know or should know, and I'll remind you if you don't know them. Okay, first of all, the total area in one revolution of a circle is A equals pi r squared. So you should know that. And remember, area measures the like kind of surface of a figure. So if you have a circle, imagine coloring it in. What does that represent? The colored in area. What is that? This is also always measured in square units. Okay, that will be important in just a minute. Okay, so if you're looking at the area of like one full revolution, so one circle, we just get this right here. Area equals pi times the radius squared. Now, we already know that in radians, if we're talking about one full revolution of a circle, the angle would be 2 pi radians. So theta is 2 pi radians for one full revolution of a circle. Okay. Now, what if instead of a full circle, we're not interested in a full circle, but only part of a revolution? So we know the area of a full revolution, we know the angle of a full revolution, but what if we're only interested in part of a revolution? Well, part of a revolution is called a sector, okay? So we're going to be looking at a sector of a circle. So think of a sector as like a slice of a circle. So like a pie piece of that circle, that's a sector, okay? And what you need to know is as the central angle that forms the sector increases and decreases, the area increases and decreases proportionally. And that should kind of make sense. If you get a larger angle, you're going to have a larger area. If you get a smaller angle, you're going to have a smaller area. So there's this proportional relationship that's going to exist, okay? So let's think about all of this. Let's kind of break things down. We should know that there's a ratio of the area of a sector to its angle. And that should make sense again. As the angle increases or decreases, the area increases or decreases proportionally. So we have this ratio, this relationship between area and angle. So the area of the sector compared to the angle that forms that sector. Okay. So if we just say A equals area and theta equals angle, the relationship between between the area of the sector and the angle of the sector is just A over theta. Okay, that's not so bad. Now, if we're talking about a full revolution, so this is just for a sector right here. If we're talking about a full revolution, the relationship is going to be the area of a full revolution over the angle of a full revolution. So that would be pi times the radius squared divided by 2 times pi, this right here. Well, we already know as an angle increases or decreases, the area increases or decreases proportionally. So we can take this information, we can take this idea of an area of a sector and this idea of the area of a full revolution, and we can create a proportion. So this right here shows us the proportional relationship of a sector compared to like the full revolution of a circle. And if we can take this proportion right here and solve for A, we have a way to come up with the area of a sector. Okay, so A was just the area of a sector. All right, so over here on the right-hand side of this box, we're going to go ahead and solve for A. Now, we have a proportion, and you may not remember this, so I'm here to remind you that when you're solving a proportion, all you have to do is cross multiply. So that means multiply like the diagonals. So one numerator, opposite denominator, one denominator, opposite numerator. So I can just cross multiply here and then solve for A. So I get 2 pi times A equals theta times pi r squared. Okay, well, we can divide both sides by 2 pi, and that'll get A by itself, right? Our goal is to solve for A, so we want to get A alone. So we're going to divide both sides by 2 pi. Well, on the left, 2 pi divided by 2 pi is just 1, so I'm left with A. But then on the right, pi divided by pi is 1, so that leaves me with theta times the radius squared over 2, or area equals 1/2 theta times r squared. They're the same thing, but a lot of times you'll see this version that I outlined and you'll see it like in your book and in Pearson. Okay. So one thing that you have to understand that when you're dealing with the area of a sector, we are very specifically talking about radians. Okay. So if you're given a measure of an angle in degrees, you must convert it to radians first. Okay. So we have now kind of derived this formula for the area of a sector. So now let's use it. So example 11, it says solve each problem involving the area of a sector, include correct units with your answer. So part A, it says find the area of a sector of a circle with a radius of 5 feet formed by an angle of 40 degrees. Round the answer to 2 decimal places. So let's kind of envision what's happening here. So we have a circle. We have a radius of 5 feet, okay? And we have an angle that's 40 degrees. So approximately 40 degrees, okay? We want to know the area of this sector right here, okay? Now, we are told that theta is 40 degrees, but remember, I told you up here that if we're dealing with the area of a sector or also arc length, we have to make sure that we're dealing with radians because all of this is based on the measure of radians, okay? So we do need to convert right off the bat. Theta needs to be converted to radians. So we have 40 degrees. Now remember, we have 180 degrees for every pi radians. So we're going to use that unit fraction to convert here because remember, a unit fraction really just has a value of 1. So we're really just multiplying by some form of 1. So I want to multiply by pi radians over 180 degrees. Well, 40 and 180 are both divisible by 20. So when I divide 40 by 20, I get 2. When I divide 180 by 20, I get 9. So we have here that we have 2 pi over 9 radians, and that's going to be our new theta. Okay, so this is theta. All right, so the area of a sector is 1/2 times theta times the radius squared. So let's fill in everything we have here. So area is going to equal 1/2 times theta, which we now know is 2 pi over 9 radians, times the radius, which is 5 squared. So let's see if anything cancels. I definitely see some 2's. 2 divided by 2 is just 1. So we get 1 times pi, which is just pi, times 5 squared. 5 squared is 25 over 9. And so this is really, you would generally write this 25 pi over 9, but let's go ahead and go to the calculator because we're told to round our answer to 2 decimal places. So we need to figure out what 25 times pi divided by 9 equals. So on the calculator, we have alpha y equals, that gives us that template for a fraction. We have 25 times pi, so remember you go second and then the little caret button, which is above division. And then we want to divide it by 9 and we need to round 2 decimal places. So we would get 8.73. So looking at this, the 2 we round up because to the right of it is a 6, so we get 8.73. So over here, we would say this is approximately 8.73. Now we're dealing with area and our unit of measure was feet. So it's 8.7 feet or 8.73 square feet. All right, so that's the area of that little darkened in pie piece. All right, now part B says, consider a sector of a circle with a radius of 6 and an area of 8 square meters. Find the angle that gives this area. So we need to think about the formula. So we have area equals 1/2 times the angle theta times the radius squared. Well, we know the radius, we know the area, we don't know the angle. So fill in what you do know. So we know that the area is 8 square meters. We don't know what theta is, but we do know that the radius is 6. So let's simplify a little bit. So I get 8 equals 1/2 theta times, well, 6 squared is 36. You could do this 2 ways. You can get rid of your fraction by multiplying 1/2 times 36, or you could multiply both sides of this by 2 and then divide. It doesn't matter. It's 6 one way, 1/2 a dozen the other. So I'm going to multiply both sides by 2. So on the right, 2 times 2 is just 1, or like 1, or 2 divided by 2 is 1, or 1/2 times 2 is 1. So the 2's on the right just cancel. On the left, we get 16. So now we have 16 equals 36 times theta. Our goal is to figure out what theta is, so we want to divide both sides by 36. Well, 36 divided by 36 is 1. 1 times theta is theta. And then we get theta is 16 over 36, but we need to reduce that. 16 and 36 are both divisible by 4. So 16 divided by 4 is 4. 36 divided by 4 is 9. So we would say that theta is 4/9 radians. And that's it. So that's how you, one, derive the formula for the area of a sector, and then how you use the formula for the area of a sector. All right.